The ceiling fan is one of the most common appliances in our household. You can connect a ceiling fan directly to the switch without a regulator. But if you need to control the speed of a ceiling fan, you will have to connect a regulator between the fan and switch. Mainly 3 types of fan regulators are available in the market: electric fan regulator, movable type electronic fan regulator, step type electronic fan regulator. The electrical regulator size is larger than the electronic regulator. Inside parts of electric fan regulators are rotating switch and multi-point resistor. This resistor is like a combination of 4 resistors connected series. And this resistance difference is making the fan speed slow and high. The rotary switch has 6 terminals, 1 input and 5 outputs. Each output terminal of the rotating switch is connected to the resistor terminals. Incoming supply connects to the input terminal of the rotary switch. And the outgoing supply connects to the 5th terminal of the rotary switch. When the knob in 5th position are high speed, the current flows directly to the fan motor, so the fan runs full speed. When the knob in the 1st position, the current flows through the full resistance of the multi-point resistor, so the fan motor gets low voltage and it runs low speed. When you moves the knob to other speeds, output voltage increases and the fan runs faster due to the change of resistance value. The main disadvantage of the electrical fan regulator is energy loss in the form of heat when fan runs low speed. The movable type electronic fan regulators have a smooth knob, which you can change the speed of the fan very smoothly. And there are no step numbers provided on them. Inside part of the movable type electronic fan regulator are potentiometer, triac, diac, capacitor and resistors. This circuit works by varying the firing angle of the triac. The alternating current has positive and negative half cycles. When we give this input to the movable type electronic fan regulator circuit, it produces a phase angle cut waveform for the fan motor. When the voltage across the capacitor reaches more than the breakover voltage of diac starts conducting. And the capacitor starts discharging towards the gate terminal of triac through diac. You can see, when the capacitor is charging, the output voltage is 0. And the capacitor discharging time, output voltage is high. Because capacitor discharging time triac starts conducting. And current flow to output through the triac. When you rotate the knob to maximum speed, capacitor charging time becomes less due to the variation of the potentiometer resistance. It makes the output voltage is high and the fan runs full speed. When you rotate the knob to minimum speed, the capacitor takes more time for charging. It makes changes in the output waveform and fan runs slow speed. The main disadvantage of movable type electronic fan regulator is fan motor makes a noise at low speed. The working of a step type electronic fan regulator is a little similar to an electric fan regulator. You can control the speed of the fan step by step. Inside parts of a step type electronic fan regulator are rotary switch, capacitors and resistors. This rotary switch working is a little different than the rotary switch we saw in the electric fan regulator. It has 1 input terminal and 8 output terminals. When you move the knob to 1st position, it connects to terminal 1. 2nd position connects to terminal number 2. 3rd position connects to terminal numbers 3 and 4. 4th position connects to terminal numbers 5, 6 and 7. 5th position connects to terminal number 8. In this circuit, capacitors are used to control the speed of the fan motor. When capacitor value increase, voltage across the fan motor also increase. Mostly its range comes to 3.3 μF, 2.2 μF and 1 μF. When the knob in 5th position or height speed, current flows directly to fan motor without the interruption of capacitors. So fan runs full speed. When you move the knob to 1st position or low speed, current flows through the 2.2 μF capacitor. And the value of current and voltage become less due to capacitor reactance. So fan runs slow speed. When you move the knob to the 2nd position, current flows through 3.3 μF capacitor. When the capacitor value increase, reactance of the capacitor decrease. So fan runs faster than in the 1st position. When you move the knob to the 3rd position, current flow through 3.3 μF capacitor and 1 μF capacitor. So the fan runs faster than the 2nd position. When you move the knob to the 4th position, current flows through all capacitors. So fan runs faster than third speed. Nowadays, step-type electronic fan regulators are most using regulators because of small size and energy-saving technology. If you liked this video, please subscribe our channel for more videos about technical doubts.